Today what we will write is Taylor series using recursion. In this video, as I've already explained in the previous video, the basic concept of Taylor series that we use summation, factorial and power. So we will implement using static variables in C++. So let's start with the basic syntax that is hashing table. These are the standard libraries that we are importing. Now what we will do is print main. We just throw the main function since it's returning int, so we will return true value which is return 0. Now back to basics. Now what we have to do is we have to print out e to the power x or Taylor series like e to the power 4 up to n terms or any terms. Like for herein I will take an example. Cout, let's print e to the power 4 comma 50. So it will print e to the power 4 up to 15 terms. So for this we have to create a new function which would be e to the power x. But point to be noted that we have to create now point to be noted that instead of int we have to write double. Instead we get more precise value in it will give integer values. So to get more precise value we have to use double. So double. Now we will declare a static variable and initialize those static variable that we already have understand in P and F. So static P is equal to 1 and F is equal to 1. We have initialized the value to 1 and as we can see, as we have earlier learned that this value will be multiplied, that this 1 will multiply to x and factorial which is in denominator would be multiplied to 2, 3 and goes on. So now let's create another variable double r in which we store the result of all three data that we will performing or all the three operations that we will performing. So now the condition goes like if x how many times n times. So if n is equal to 0, if n is equal to 0, what would be the output? Like there is no term. So what would be the output? It would be literally 1. Like if n is e to the power 0 is 1. So we will return 1. Else what we'll do is in r we will write e x minus 1. What we did here is that we called a function as we have seen earlier. We have called a function and again call and again call. We have kept calling and then summation is done. So here, as in the previous example, we have called e to the power 4. So that fourth term calls the third, second, first, and 0. And after 0, it goes back to the first, 2, 3, 4. So this is the function call. It is decreasing the value by -1. Now p is equal to p equal to We multiplied x. As the x in numerator, the x was increasing, and f is equal to f into n. So this number will be multiplied to f for to get the factorial, and we will just return the value of r plus VIF. VIF. So if n is equal to 0, it will return this, else it will perform these operations. And in these operations, let's see what's happening over here is in R it's stored the value, the function is called using recursion, which is decrease. This is called, now this value, as we have called e to 415, so the value is 4 and 15. This 4 is here, 4 and 15 minus 1, which is 14. Uh, this e would be here, 14. And now again the function call is done. Now again the function call is done. So we have seen the function calling keeps on going like a tree, and after the first, like the end term of function call is called, so it will go to the next line and it will add, and this is stored in static variable, so the value will keep on increasing by or multiplied by x, and here the denominator would be multiplied by n, and n is the value that we want, as here in the 15th. So let's see the problem. It shows the problem, which is line 2. So there is a problem, hash includes stdio.h Now everything is right. So I would just save this. So let's run this program. It will show 54 point. Yes, it shows 54.5979. You can see in the compiler also, or like online. So I've already opened this e to the power x value 4 up to 15 terms. It shows like 54.59. If you write more, it would be give more precision. Like if I write like let's say 20, so it will be more precision. So let's save this first of all. Now run again. So we can see it run. So the value has changed. The more the values, the more the precision over here. So that's how it works. And thank you.